Okay, guys, so I'm gonna ask you to pause the video and try doing this interesting starter question. So again, this has to do with unit analysis. I've given you a hint, right? There's this formula that tells you how to calculate speed. So please pause the video and try doing this question on your own. Um, and then you can compare answers later on. Okay, so I'm going to proceed though. So using the hint, I know that speed, I'm just going to use S, is equals to distance divided by time. So Usain Bolt um, runs 100 meters in 9.58 seconds, right? But if you divide this out, right, the problem is um, you're gonna get a right answer, which is close to 10.44 meters per second. So that's his average speed when he runs 100 meters. But the question is asking you to find the speed in kilometers per hour, right? So this, even though it's right, that's not what the question is asking you to compute. So how can we um, find the right answer? Well, you're gonna have to rely on unit analysis. Okay, so how do you do that? So I'm gonna start off with the information that I'm given, right? So I have 100 meters over 9.58 seconds. Now here the problem is I have two units, meters and seconds, and both of them need to be changed, okay? Because I want kilometers and I want hours. So what needs to be done is you need to change one unit at a time and it will work out, okay? So what do I mean by that? So I need to, it doesn't matter what you choose to get rid of first. I'm gonna choose to get rid of my seconds first, right? Because my seconds is in the denominator, when I multiply this, I have to make sure that my seconds goes in the numerator so that they can cancel out, okay? So the S and the S will cancel out, right? So they have to be um, opposite to each other, okay? So now I want my units of time to be hours, right? But it's kind of hard to know how many hours there are. Sorry, how many seconds there are in an hour, right? Some of you probably don't know this. Um, so let's change this into minutes first. Okay, so I know that 1 minute is actually equals to 60 seconds, right? So now by doing this, I am able to cross out my seconds, but I'm still not done because now I need to get rid of minutes, okay? So you multiply again, right? So times, I know that my numerator has to have the units of minutes, and my denominator, well, I know that now there's a relationship between hour and minute, right? We know that there's 60, or there are 60 minutes in an hour. So that works out for me. Now I can cancel the minute and the minute, okay? And I have what I want for my time in hours. But let's not forget about the distance. My distance is still in meters, okay? So I need to get rid of that as well. So I'm going to multiply again, okay? Multiply again. I need to get rid of meters, right? So because my meters is on top, that means I need to put meters in my denominator so that they can cancel out. Um, so I will find a relationship between meters and kilometers. And again, if you're looking at your table, you will find this, but I think it's common knowledge by now that 1 kilometer is actually 1,000 meters, right? And now you have everything that you need, right? Because your meters will cancel out. So maybe let me use a different color for the distance. Meters and meters will cancel out. That leaves you with kilometers on top, right? And hours at the bottom. Okay, now all you have to do is just multiply the fraction. Okay, so multiply all your numerators together and then multiply your denominators together. and then divide. Okay, so we're going to multiply the top. So we have 100 times 60 times 60 times 1. So I get 360,000 on top. And at the bottom, I have 9.58 times 1 times 1 times 1,000. Okay, so that gives me 9,580. Right? And when you divide this using your, and remember, on top you have kilometers, right? And at the bottom you have seconds. Sorry, hours, right? Hours, kilometers per hour. So if you divide 360,000 by 9,580, you will get 37.58 kilometers per hour. Okay, which kind of makes sense, right? We're talking about Usain Bolt, so the 37.58 kilometers kind of makes sense. Now this has nothing to do with the math class, but I'm actually going to point out something. uh Usain Bolt actually runs faster than 37.58, because this, remember guys, is his average speed, right? So because if you've seen Usain Bolt run, he starts off slow, right? So there are people actually ahead of him when he starts, but like after 40, 50 meters, he attains his maximum speed, and then he starts passing them one by one. His maximum speed, I think, is close to like 45 kilometers an hour. Again, you can Google this information. So this was just a side note, just to make this a little bit more interesting. Um, but I hope this kind of made sense. Now, on the quiz, you're not going to get a question this difficult, but if this question makes sense, then the quiz will not be as challenging, right? And remember, the quiz for this week will be your homework, okay? So, mandatory homework. So, the focus of today's class is surface area. Now, one way to visualize surface area is, think about, if we're talking about a pyramid, okay? So let's say this is a small pyramid that you can hold in your hands. When we're asking you to find the surface area, it's the area that you can actually paint, right? So when it comes to a pyramid, you can paint the the triangles, right? And also the base, because if you can lift the pyramid, turn it upside down, you can also paint the base, which is where this formula is coming from. Okay, so the total surface area will be area of the base, right? You can paint the base, and the area of, if you want the walls of the pyramid, right, which are triangles. So that's what we call lateral area. Okay, so when you add them up, you're gonna get the total area. Now, before this formula, I hope makes sense. This will be given to you. So that's one way of visualizing this formula, right? The area that can be painted. Um, so before we start using the formula, I'm just gonna point out a few things that throw students off. There are some definitions. So apex, think of the apex as, the meeting point of your walls, right? And your walls here are triangles. They don't go straight up. They're kind of like inclined, and they meet at this top point that we call apex. Okay, this definition is not super important, but what is really important is height. Okay, so there's the height of the pyramid, which is the height inside your pyramid. Okay, so this is useful when you're calculating um, volume. Okay, so this is useful for volume, but when you're finding surface area, you're not interested in this height, which is inside your pyramid. You're actually interested in slant height. Now, see, both of the words are use the word height in there, but there's a key difference. Slant height is the height of your triangle. It's the height of um, the wall, right? So when you're finding surface area, right, your goal is to find the area of this triangle. So because you have to find the area of this triangle, then you will have to use the height of this triangle, not the height of the pyramid. Okay, this is irrelevant when it comes to, this height is not important for surface area. Okay, not important. Not important for, I'm just gonna call surface area SA, okay, and save ourselves a lot of time, okay? So know the difference between the two. Now, for my French immersion students, this should not be too difficult because um, in the immersion textbook, slant height is known as apothème, okay, or apothème, I think in English. So you know they are using a completely different word, so maybe they might not get as confused as you guys will. Know the difference between the two heights, okay? This one is important for volume, and this one here is important to find the surface area, okay? So this one is not important for surface area, but this one is. So let me point this out maybe. Okay, this is important, right? Important for surface area. Okay, and the formula, right? So again, everything that can be painted, right? So you can paint the base. So that's where AB comes from. This is the area of the base. Area of base, right? And AL stands for lateral area. So that's the, maybe let me use a different color for this. By that I mean the area of, actually hold on, the area of your wall. Okay, so in the case of the pyramid, the walls are made up of triangles, right? So remember, if the base has four sides, then you will have four walls, right? Think about the classroom, because the classroom floor has four sides, right? It's a rectangle, you have four walls. Same logic applies to pyramids. Okay, so this is your lateral area. I'm not too sure how you spell that, but I think it's Lateral area, okay? And by lateral, we mean the area of the walls, okay? So let's do an example and hopefully this will make more sense. Okay, so key thing to note is, right, when you see a pyramid, because it's a 3D picture, sometimes we tend to forget, um, it's hard to visualize, right? So one way to visualize this is by drawing a net. You don't have to do this, but what this shows you that is that if you cut the pyramid open, you will have a base, right? So, and then you will have, if the base has four sides, then you'll have four triangles, right? So, how can you find the area? Well, just find the area of the base, find the area of one triangle, multiply that by four because there's four of them, and you will have your answer, okay? So, let's do that. And which is what the formula tells you to do anyway, right? So SA, surface area, is equals to the area of the base plus AL, which is the lateral area. Okay, so let's find AB, area of base. Now, if you read the question carefully, right, it says calculate the surface area of a square pyramid. Now, square pyramid, when we use the word square, we're always talking about the base, okay? So if we say calculate the area of a um, triangular pyramid, then that means the base is made up of triangles. Because regardless of the shape that the base has, the walls will always be triangles, right? So when you see the name of a shape, it refers to the base, okay? So because the base is a square, right? And we know that one of the sides measures 8, that means the other one also has to measure 8, right? So area of the base is just 8 times 8, which is 64. Now, how do you find the area, the lateral area? Well, you have to find the area of the triangle. So let's do that first, okay? So because I don't want to confuse you, so let's find the area of the triangle first. So A, um, I'm just gonna put tri for triangle. Okay, so area of triangle, the formula on the quiz will, well, I mean, because the quiz is open book, I'm not going to give you any formulas. Okay, so, but by now you should know what the area of a triangle is. It's just base times height divided by 2, right? So if you look at this picture over here, right, that I have, um, you know, made really ugly, so I'm going to erase everything so that it's more visible, right? So because it's a square, if this side is 8, then this side also has to be 8, right? And now you have your triangle. So the base of the triangle is 8. The height of the triangle here is 10, right? And then you have to divide by 2, okay? So please don't forget to divide by 2 because that's a common mistake that students make all the time, okay? So 10 times 8 is 80, and then 80 divided by 2 is 40, okay? But this is the area of the triangle. It's not AL, okay? AL is actually equals to, because I have 4 triangles, right? 1, 2, 3, 4. I'm going to have to multiply 40, oops, 40 by 4, which gives me 160. And now I have everything, okay? So as you can see, guys, I'm not putting the units in because I usually put my units in for my final answer only. But if you would like to add your units for everything, you could do so. I am not going to be picky, but I'm going to be picky when you write your final answer. So SA is equals to AB. So AB, which is this, plus AL, which is this, right? So let's write this out. AB is 64 plus 160. And if you add this up, I think it's 224, but let me check. Yeah, 224 to okay, 224 centimeters squared. Okay, so here I want you to put the units, okay? If you don't put the units here, here, and here, I am not going to dock any marks off, but on the final answer, you should have your units, okay? Perfect. So I hope this kind of made sense. Again, this should be more of a review than anything, okay? Because I'm pretty sure you guys have seen this in grade 9. Now let's do another question. So again, it's always a good idea to read the question, okay? So Jean-Marie measured, then recorded the length of the edges and the slant height of this regular tetrahedron. What is its surface area to the nearest square centimeters? Now, there's a question like this that will be assigned in the homework. What you need to understand is the word tetrahedron. Okay, so tetrahedron is a special pyramid which is made up of 4 equilateral triangle. Okay, so you see the base has 3 sides, so there's one triangle in the base, and because the base has 3 sides, your walls also there will be 3 walls, right? So altogether there are 4 triangles, and they're all the triangles are equilateral, right? So that means if you can find the area of one triangle, then you can just multiply that by 4 to get the total area, okay? So in this case, um, you don't have to use your fancy formula, right? You don't have to use SA is equals to AB plus AL. You could, because this is the area of one triangle, and this is the area of 3 triangles, right? And if you add them up, it's basically equals to the area of one triangle, right, times 4. Okay, so you just find the area of one triangle and multiply that by 4. Okay, so no need to use the formula because I mean it will work, but it's just longer. I think this would be much faster. Okay, so let's do that. So the area, oops, area of one triangle is just equals to base times height divided by 2. So my base, right? So remember, because the triangles are equivalent, if this base is 9, right? So if this base over here is 9, then this one also has to be 9, okay? So, and my height is 7.8, right? So it's just 9 times 7.8 divided by 2, right? Again, don't forget to divide by 2. So 9 times 7.8 divided by 2 is equals to 35.1, okay? So let me just check this one more time. 9 times 7.8 divided by 2. Yeah, 35.1. Now the surface area is just equals to 4 times 35.1. Okay, so this is times. And so if I multiply 35 by 4, I'm going to get 140.4, right? Make sure you put your units, centimeter squared, because this is your final answer, okay? So key thing to kind of like take away from this question is the word tetrahedron. I hope I'm pronouncing it the right way. But that is a special um, 3D shape, right? That is a pyramid, but it's a special pyramid in the sense that all the sides, right, all the faces of that pyramid are made up of equilateral triangle. Okay, so if you can find the area of one triangle, right, 35.1, and multiply that by 4, then you're going to get the total surface area. Okay, so let's move on to the next question. So now this one is a challenging one. Okay, so here let's read the question. A rectangular pyramid. Right just means that the pyramid is straight. Okay, so it's not like slanted towards one side or anything. It's um, it goes straight up. It's not crooked. Okay. So a right rectangular pyramid has base dimensions of 8 feet by 10 feet and a height of 16 feet. Calculate the surface area of the pyramid. Now, here you have to be careful. See, they're using the word height, right? They're not talking about slant height. So that means you'll have to calculate the slant height separately using the Pythagorean theorem. Okay, so again, my drawing is not that great. So let me just draw this pyramid as best as I can. Okay, so maybe something like this. And then if this is my apex, and then if I connect all, so maybe something like this. Okay, so again, not the best drawing, but what they're giving you is um, the dimensions of the base. So this looks kind of smaller, so let's just call this 8. This is 10, and they're giving you the vertical height. Okay, so I'm gonna draw this in blue. So this is inside your pyramid. Okay, and it touches the middle of your pyramid. So this is the height of the pyramid, which is used to calculate the volume. Okay, um, and that measures 16 feet. Okay, so everything is in feet. Okay, so let me just add that here. But you see, the problem is I'm not interested in this. What I'm actually interested in is the slant height. Okay, so I'm just gonna do this. I'm gonna shade over here. This slant height is what I'm interested in. Okay, but once you draw this picture, right, you will see that it's actually a right angle triangle. Okay, so because this is 90 degrees, so let me redraw the triangle, and you will see this triangle in the textbook as well. Maybe for reference, you can just look at the textbook. It's exactly the same question. Maybe those guys did a better job than I did. Okay, so this is your height, right? And then you have this dotted line in green. Okay, so let me just draw this in green. And now this not well drawn, so maybe something like this. Okay, this is what I'm interested in. This is my slant height. Okay, now to find the slant height, I will have to use the Pythagorean theorem. I know that the height of the pyramid is given to me, so I know that this is 16, right? I don't know what the slant height is. Okay, so this will be x. Now you might think that you don't know what this value is, right? You might think that maybe I should have used a different color for this, but you might think that you don't know what this value is. Okay, so let me just use red. Okay, so you might think that you don't know what this is, but you do. Okay, because as you can see over here, the height always touches the middle of your pyramid. So that means that if this over here, so let me use a different color. If this length is 8 feet and this touches the middle of that, right? So that means this piece over here in purple is actually half um, of this length, right? Because 8 is the whole thing. This is just half as much. Okay, so let's be consistent with the colors. So let's just change this to purple as well. Now, if this is 8, this has to be 4. Okay, and now because it's a right angle triangle, right? Because by definition, the height has to be perpendicular to the base, right? So this is a right angle triangle. You can use your favorite Pythagorean theorem. So remember the formula is um, a squared plus b squared is equals to c squared, right? C is always opposite to the 90-degree angle. Okay, so just to make things a little consistent, why don't I change this x to c? Okay, because and you could call this A and this B. It doesn't matter. Okay, so you could have chosen this to be B and this to be A. It would still work because the legs, right? We call them the legs are irrelevant. Okay, the only thing that actually matters is the C value, and the C value always has to be opposite to this 90-degree angle. Okay, opposite. So based on how I've labeled it, right? My A value is 16. But I have to square my A value. So 16 squared, and my B value is 4, but I have to square my B value. So 16 squared plus 4 squared is equals to C squared, right? And now if you add them up, 16 squared plus 4 squared, right? If you do this in your calculator, you should get 272, okay? And maybe, I'm not going to skip any steps. So 16 squared is 256. 4 squared is 16, and this is equals to c squared. And when you add them up, so plus 16, you will get 272 is equals to c squared. Now guys, just remember that we're not interested in this. This is c squared. I'm not interested in the c squared value. What I want is the c value. So I need to get rid of this squared term, right? And algebra tells me that when you want to get rid of something, you have to take the inverse, right? So the inverse of squared is square root. So let's take the square root of that. And c, if I take the square root of this, 272, then c will approximately equals to 16 point. Let's just stick with one decimal place, right? So let's just say 16.5 now, because everything else is in feet. This also has to be in feet, okay? And now I have everything that I need, okay? Now I have everything that I need because I have the slant height, right? So I'm going to use my formula. So the formula that I gave you, right, on this page, this important formula over here, surface area is equals to the area of the base plus the lateral area, okay? So let's use that formula and find out the answer. So I'm going to use the red color. So SA is equals to AB plus AL. So let's find AB, the area of the base, right? Because my base is a rectangle, it's 8 feet, right? So again, 8 feet over here, and then 10 feet across, right? So it's just 8 times 10, right? So 8 times 10, which is 80. Now, how do you find the lateral area? Again, your walls are made up of triangles, right? So you find the area of one triangle, and then you have to multiply by 4 because there's actually 4 triangles because your base has 4 sides, right? So the area of one triangle is equals to base times height divided by 2, okay? But this height is the slant height, right? This one, um, so maybe, you know what, let me be consistent with my colors. So I'm gonna put a green color for this, okay? Because it has to be consistent with my slant height, okay? So this is my slant height, which I calculated over here, okay? So my base, like by looking at this picture over here, my base is 10 and my height is 16.5, okay? So I'm going to replace b by 10 and then multiply that by 16.5 and then don't forget to divide by 2, okay? So when you multiply everything out, 10 times 16.5 is just 165, right? And you divide that by 2, you get 82.5. Now, this is just the area of one triangle, right? So if this doesn't look good to you, this was just TRI. So this is the area of one triangle, which is not my lateral area, right? AL is actually equals to 4 times 82.5, which is equals to times 4, 330, okay? And now my surface area, right, is equals to the area of the base. So the area of the base, which I calculated was 80, plus my lateral area, which is 330, okay? Then when you add them up, you're gonna get plus 80. So 330 plus 80 is 410, I believe, right? Yep, 410 feet squared, okay? Because again, the area is always, the units have to be squared. And I want you to put your units for the final answer, okay? So hopefully that kind of made sense. Now, one last thing that I'm going to discuss today is how do you find the surface area of a cone? Now, maybe this might be new to you, okay? I'm not too sure. But you see, if you understood how this formula um, was derived, then this, um, for pyramid, then we can actually use the same formula for cone as well, okay? But now your base has changed, right? Your base now is a circle, okay? So we're gonna use the same formula, right? So you find the area of the base and then you have to find the lateral area, okay? So area of the base should be fairly, how do you get rid of this? Give me 1 second. Okay, I just did. So area of the base should be fairly straightforward, right? So surface area is equals to, because it's a circle, right? My base area will be pi r squared, okay? Because it's a circle. Now the tricky part over here is, what is the lateral area, okay? Now I'm not going to show you the proof because this will take a lot of time, but it turns out that the lateral area can be calculated using this formula. Pi times r times s, okay? So s, think of your s as kind of like the slant height in the pyramid, right? For the pyramid. And r is the radius of your circle, okay? So r over here, right? It's the same r um, as this, which is the radius of your circle. So as long as you have r, which is the radius of your circle, and this s value, which you can kind of think of it as a slant height, you can find the lateral area, okay? The base area, I'm pretty sure, should be slightly familiar to you because that's just the formula to find the area of the circle, okay? This one, guys, is tricky. You can prove that it's pi rs. I'm not gonna do that. If I don't know, maybe if we were still having classes in school, I would have done that. But to save some time, we're just gonna accept the fact that AL, the lateral area, is just pi rs. Okay, so I just want you to believe me. Okay. But if you're curious, you can look it up on Google. It's not that difficult. So let's apply the formula. Let's do one example. Okay, so surface area, right, guys? The formula is the same. It's the area of the base plus the lateral area, okay? Now, because my base is a circle, um, I'm going to do this separately, okay? So how do you find the area of the base? And you know what? Maybe let me just use different colors, okay? So let's just use green for this, AL, okay? To be consistent with the previous page. So area of the base, my base is a circle. So the area to find The formula to find the area of a circle is pi r squared. Pi is roughly 3.14, right? Radius is given to me, it's 2, right? This is my radius, right? The radius of the circle, and then you have to square that, okay? And when you multiply this out, remember guys, pi is a constant, right? It has a constant value of 3.14. It never changes, okay? So that's where the 3.14 is coming from. So 3.14 times 2 squared is 12.56. This is actually, in my opinion, the cone is easier than the pyramid because you can directly find your lateral area, right? You don't have to find the area of one triangle and then multiply that by 4 or how many triangles there are, right? You can find it directly using this formula. Pi times r times s, okay? But I have a problem, okay? I have a problem because I know what r is. R is 2, right? So r is 2, so this is my r. But I don't know what my s is. Okay, so I'm gonna have to use the Pythagorean theorem again. So let's draw this triangle, this one over here. Um, so let's use purple for this height. Okay, so this is in purple, and then S is in green. Okay, so this is a triangle that I'm interested in. Okay, so if I draw the same triangle separately on this side, I have this triangle with, so this red piece, right, is the radius. So I know that this is 2. The height of the cone, again, this height, because it's inside the cone, it will be useful when we talk about volumes, which will be the focus of next class. But here we're not talking about volume. So this one is not important for now, okay? What I am interested in is, remember, this is a right triangle, right? Because there's a 90-degree angle, as you can see, right? The height always makes a 90-degree angle. And this is my, right, opposite to the 90 degree. This has to be C, right? The hypotenuse. So how can you find the C value? Just use the Pythagorean theorem, right? So I'm not going to write everything out, but it's basically you square the leg, right? So 7 squared plus 2 squared is actually equals to C squared, right? And then 7 squared plus 2 squared is 49 plus 4, which is 53, I think. So C squared, or let me just be consistent. So 53 is equals to C squared, and then you can easily solve for C by taking the square root, right? Because the square root is the inverse of squared. So that means that C is roughly equals to square root of 53, and that is 7.28, okay? So this C value over here is actually, right, my S value, right? So I just called it C, but this C is also equals to the S value, right? Based on this picture. So let me clear the picture up a little bit and then you will see, right? So this S over here, right? This S is the same as my C, okay? So now I have my slant height, okay? So I have everything that I need. 3.14 is my pi value times r is given to me. It's just 2. And the s value is right here, right? My s value is my c value, which is 7.28. And then if you multiply this out, you will get your answer. So 3.14 times 2 times 7.28, that gives me close to 45.72. Okay, again, I'm here for some reason I'm rounding it to 2 decimal places. If you're rounding it to 1 decimal place, that's also fine. Okay, but I'm not done. I'm not done because what I have right now is just my lateral area, right? What I'm interested in is the surface area, so I have to add the two. So surface area is equals to AB, which is 12.56, right? Plus AL, which is 45.72. 45.72. And when you add this up, 12.56 plus 45.72 gives me 58.28. Because again, everything was in feet, so it has to be feet squared. Okay, so make sure you are putting your units in your final answer. And that is it, guys. Okay, so this covers everything that you need to know for surface area. For homework, I just want you to do two questions, okay, today. Question 4 and question 8. And that is it, okay, because I know that today's video was kind of long. So I think one of the questions will ask you to find the surface area of a cone, and the other one will ask you to find the surface area of a pyramid. I think this one, the 4 might be the pyramid, the 8 might be the cone. Not too sure. So that's on page 34. So make sure you get that done, and check your answers with the backside of the book. Okay. And your textbook, again, guys, your textbook is on Google Classroom. Okay, so I know that for my English students, I was printing the exercise questions separately, but I have uploaded the whole textbook on Google Classroom, so just please find that. Okay, if you can't find it, send me an email. I will upload it again, I guess. Okay. Okay. So thank you so much for your time, guys. You have a nice day.